Trig identities and inequalities have special pitfalls because you're going to want to try to divide out things, and you can't do that. If I were to just divide out cosine of x, then I would get x equals 3. But that is incorrect because on this domain from 0 to 2 pi, cosine x is 0. So never divide out. That's just a good practice. What you want to do is factor. You will hear me say this repeatedly in class. So x cosine x minus 3 cosine x equals 0. Now I'm going to factor out cosine of x times x minus 3. All right, so this is 0 whenever cosine of x is 0. Now cosine of x is 0 on 0 to 2 pi when x is pi over 2 and 3 pi over 2. You have to work in radians. You can never say, 90 degrees. That makes no sense. X minus 3 equals 0 when x equals 3. So here are my solutions. I'm going to box them for you. Now, what if I want to solve something like this? I don't have everything in nice, neat sines and cosines. So I'm going to try and get all the x terms on one side and all the numbers on the other side. So tangent of x plus sine squared x plus cosine squared x equals 2. Now this is looking promising because what do I know sine squared plus cosine squared is? Well, it's 1. So tangent of x plus 1 is equal to 2. So tangent of x equals 1. All right, so on 0 to 2 pi, this is true when x is pi over 4 and 5 pi over 4. Now, I have 3 tan squared x minus 1 equals 0. Let me get all my numbers on one side. So 3 tan squared x equals 1. Or tan squared x is equal to 1 over the square root of 3. Oh, 1 over 3, sorry, got carried away. Doing steps ahead. So tangent of x is plus or minus, and you do need the plus or minus, the square root of 1 over 3. Now, on 0 to 2 pi, where is this true? Well, this is true for x, pi over 6, 5 pi over 6, 7 pi over 6, 11 pi over 6. Now what if I want to solve this one? And you'll notice I have cosines and sine squareds. Yuck. Now remember I told you you're going to have to translate things, or you're going to have to change them around a little bit. I don't want to change cosine, but I know I can get sine squared in terms of cosine, or at least cosine squared. All right, so this becomes 3 cosine x is 2 minus 2 cosine squared x. Let me get everything to one side. 2 cosine squared x plus 3 cosine x minus 2 equals 0. Now this is a quadratic. If I let y equal cosine of x, then this becomes 2y squared plus 3y minus 2 equals 0. And so it's very straightforward to see that this becomes 2y minus 1 times y plus 2 equals 0. All I've done is factor it. Now I'm going to replace this back in. 2 cosine x minus 1 times cosine x plus 2 equals 0. You do not have to do this step, but I find it's very helpful. All right, so when is 2 cosine x minus 1 equal to 0? Well, that's when cosine of x is 1/2. So this is when x is pi over 3 and 5 pi over 3. Remember, we're restricting ourselves to 0 to 2 pi. Now, when is cosine x plus 2 equal to 0? And the answer is never. There is no solution here. So this is my only answer. Now, what do you do when you get something like this? I can't simplify this, but I want this whole thing to be positive. Now, I notice that my denominator is always greater than or equal to 0, but I first need to check to see where is sine squared equal to 0, because obviously these points will not be in our domain. And this is 0 when sine is 0, or it's 0 in pi. Now, you know I'm going to do a number line. All right. Okay, and I'm going to start at 0. And here's pi, and we're restricting ourselves to 2 pi. Now, I'm not including 2 pi, so I'm going to put a circle there. I can't include 0 or pi because those are outside of our domain. Now I'm going to look at the numerator. 2 cosine x plus 1. Now, sine squared is always going to be positive or 0, and I've already pulled out the points where it's 0. So basically, I just need the numerator to be positive. So first of all, let's just find out what the zeros are. 2 cosine x plus 1 equals to 0 when cosine of x is equal to minus 1/2. So I'm looking at the x values, 2 pi over 3, 4 pi over 3. So I'm going to come over here and put in my 2 pi over 3 and 4 pi over 3. Now, where is, when I am between 0 and 2 pi, this function is positive. Between 2 pi and over 3 and 4 pi over 3, 2 cosine x plus 1 is negative. And between 4 pi over 3 and 2 pi, this is again positive. So my solution is, let me come over here and put it in red. My solution, now I can't include 0 because sine is 0 there. So it's 0. 2, I want it to be positive, so it's got to go to 2 pi over 3. Now I want it to be strictly positive, so I can't include that point either. Okay, and that's going to union with 4 pi over 3 to 2 pi.